The measure of heat energy going into or out of an object can be computed using this formula. So Q is equal to mc delta T. Q is the heat energy, usually in joules. M is the mass of the object. It could be kilogram or gram. C is the specific heat capacity of the object. It's usually in joules per kilogram per degree centigrade or joules per gram per centigrade. Delta T is the change in temperature. So here are the specific capacity of some objects. So the specific heat capacity of water is 4,184 joules per kilogram per degree centigrade. This means that it will need, or it will take 4,184 joules for every kilogram of water to increase or decrease it by 1 degree centigrade. So if you will notice, the specific heat capacity of water is way higher than copper or stainless steel. So this means that it will take more energy in water as compared to copper or stainless steel to increase it or decrease it by 1 degree centigrade. So example 1, what is the amount of heat removed from an object when its temperature is decreased from 48 degrees to 18 degrees centigrade? Its mass is 2 kilograms and the specific heat capacity is 477 joules per kilogram per degree centigrade. So we will just apply all the values into our formula. So Q in here, what is the amount of heat? So Q is unknown. So Q is equal to the mass. Our mass is 2 kilograms. 2 kilograms. And then the specific heat capacity is here 477 joules per kilogram degree centigrade. And then the delta T, so from 48 degrees to 18 degrees, that is 30 degrees centigrade. Okay. So in here we can cancel kilogram and kilogram, centigrade and centigrade, and what will be left will be joules. So if you multiply 2 times 477 times 30, the answer is 28,620 joules. So this is your heat. This is the amount of heat removed from the object when the temperature decreased from 48 to 18 degrees centigrade. Example 2. What is the increase in water temperature if 10,041.6 joules of heat energy is transferred into 300 grams of water that is initially at 25 degrees centigrade? So again, we just plug in the values into our formula. So what is the increase in water? So we have Q, which is 10,041.6. So Q is 10,041.6 joules is equal to the mass. Our mass is in grams, but our specific heat capacity is in kilograms, so we have to convert this into kilograms, so 300 grams. So one kilogram is 1,000 grams. So grams is on top. We have to put the grams in the bottom. 1,000 grams, 1 kilogram. So this will cancel out. 300 divided by 1,000 is 0.3 kilograms. So we, instead of putting these 300 grams, we put 0.3 kilograms. So we have consistent units. Now the specific heat of water is this one, 4,184 184 joules per kilogram per degree centigrade, and change of water. So your delta T is your unknown. You don't know the change in temperature. So this one, kilogram and kilogram will cancel out. We can multiply 0.3 by 4,184 joules. That would be 1,255.2 joules per degree centigrade. So we still retain the units. Joules per degree centigrade is times delta T is equal to 10,041.6 joules. So we want to solve for delta T. What is with delta T? This whole lot. So we multiply both sides of the equation by this whole lot. So what we'll have is 10,041.6 joules divided by this 1,255.2 joules per degree centigrade is equal to delta T. So this will cancel out. Joules and joules cancel out. Degree, when you this will come out on the numerator. So 10,041.6 divided by 1,255.2 is exactly 8. And the unit is in degrees. So this 8 degrees is your delta T. This is your change in temperature. Now, in here is the question is, what is the increase in water temperature? So if you want the increase, this is your answer. But if you want the final temperature, the initial temperature is 25. There is an increase of 8 degrees. So your final temperature will be 25 degrees centigrade plus 8 degrees. So your final temperature is 33 degrees centigrade. This is your final temperature.